This video is an introduction to SCADA, or Supervisory Control and Data Acquisition. First, let's start with the definition of SCADA. Any application that gets data about a system in order to control that system is a SCADA application. You can build a SCADA system using several kinds of technologies and protocols, given that those technologies and protocols have a way to communicate with each other. There are two elements of every SCADA application. First is the process, system, or machinery that you want to control and monitor. This can be a power plant, a water system, a network, a system of traffic lights, or anything else. The second element is a network of intelligent devices that interfaces with the first system through sensors and control outputs. This network, which is the SCADA system, gives you the ability to measure and control specific elements of the first system. Where is SCADA used? Typically, SCADA systems are used to automate complex industrial processes where human control is impractical. So these are the examples. First, we have electric power generation and transmission and distribution. So electric companies actually generate power from power plants, and then they transmit those power through transmission lines to be distributed to household. So they need a way to measure how much electricity does this specific portion of the neighborhood needs, and they send around the same power that the neighborhood requires. Second, we have water and sewage. So the data monitoring of water consumption and the sewage treatment plant, for example, is controlled by SCADA, and even sewage networks under the cities are sometimes monitored by SCADA applications in case of overflow. Buildings, facilities, and environments. Of course, in buildings, we have CCTVs, and then there are parts of buildings wherein, for example, automatic lock on the doors or automatic unlock can be controlled by SCADA. For manufacturing, almost every step of the manufacturing process is controlled by SCADA. And then for mass transits, we have the train, of course. The train monitors if there are obstacles in its path, and in every station, it should be able to stop. And traffic signals, there are some smart traffic lights wherein the stop and go signal will depend upon the density of the vehicle in the certain lanes. Now, what are the advantages of SCADA? First, it lets us have access to quantitative measurements of important processes, both immediately and over time. It can detect and correct problems as soon as they begin. And using SCADA, we can measure trends over time. We can also discover and eliminate bottlenecks and inefficiencies in processes. And last, we can control larger and more complex processes with a smaller and less specialized staff. There are four functions of SCADA. First are the data acquisitions. These are accomplished by different sensors, equally spaced out or smartly spaced out in a network. Then we have the network data communication. This is done by remote telemetry units or RTUs. Third, we have data presentation. So this is usually placed in the main facility, and it is presented by SCADA Master units. Lastly, we have the control, which uses communications network. The world's simplest SCADA system. The simplest possible SCADA system would be a single circuit that notifies you of one event. Imagine a fabrication machine that produces widgets. Every time the machine finishes a widget, it activates a switch. The switch turns on a light on a panel, which tells a human operator that a widget has been completed. Obviously, a real SCADA system does more than this simple model, but the principle is the same. A full-scale SCADA system just monitors more stuff over greater distances. Now let's take a look at the first function of SCADA, data acquisition. A real-life SCADA system needs to monitor hundreds or thousands of sensors. Some sensors measure inputs, some outputs, some discrete, and some analog. For most analog factors, there is a normal range defined by a bottom and top level. In more advanced systems, there are 4 threshold alarms for analog sensors, defining major under, minor over, and major over alarms. In real life, you want to be able to monitor multiple systems from a center location. Sensors and control relays are very simple electric devices that can't generate or interpret protocol communication on their own. Therefore, the remote telemetry unit, or RTU, is needed to provide an interface between the sensors and the SCADA network. The RTU encodes sensor inputs into protocol format and forwards them to the SCADA Master. In turn, the RTU receives control commands in protocol format also from the master and transmits electrical signals to the appropriate control relays. Now, in this situation, our sensors are the input and the control relays are our output. The third function of a SCADA is data presentation. A real SCADA system reports to human operators over a specialized computer that is variously called a master station, an HMI or human-to-machine interface, or an HCI, a human-to-computer interface. The SCADA station has several different functions. First is to continuously monitor all sensors. Second is it alerts the operator when there is an alarm. Third, it presents a comprehensive view of the entire managed system. Fourth, it maintains report logs and summarizes historical trends. And lastly, an advanced SCADA Master can add a great deal of intelligence and automation to your system's management if properly programmed. The last function of SCADA is control. SCADA systems automatically regulate all kinds of industrial processes. For example, if too much pressure is building up in a gas pipeline, the SCADA system can automatically open a release valve. Electricity production can also be regulated to meet demands on the power grid. If you have a sufficiently sophisticated master unit, these controls can run completely automatically without the need of human intervention. Of course, you can actually still manually override the control from the master station. This is for safety purposes. For practical applications, these are what to look for in a SCADA RTU. First is the sufficient capacity. The RTU must have a sufficient capacity to support the equipment at your site. At every site, you want an RTU that can support your expected growth over a reasonable period of time. But of course, it is simply wasteful to spend your budget on excess capacity that you will never use. So you must find a balance between these. Second, your RTU must have the ability to withstand extreme temperature and humidity. So you must make sure it has a rugged construction. Third, your RTU must be secure and you have redundant power supply. You need your SCADA system up and working 24/7, no excuses. Your RTU should support battery power and ideally 2 power inputs. Your RTU must have redundant communication ports. Network connectivity is as important to SCADA operations as a power supply. A second serial port or internal modem will keep your RTU online even if the LAN fails. Plus, RTUs with multiple communication ports easily support a LAN migration strategy. Next, non-volatile memory. This is for storing software and firmware. Non-volatile memory retains data even when the power is lost. New firmware can be easily downloaded to this memory and often over a LAN, so you can keep your RTU's capabilities up to date without excessive site visits. Next, intelligent control. Sophisticated SCADA remotes can control local systems by themselves according to program responses to sensor inputs. This isn't necessary for every application, but it does come in handy for some users. Next, we have real-time clock. This is for accurate date or time stamping of reports. And lastly, the Watchdog timer. This ensures that the RTU restarts after a power failure. We've seen what you need to look for in a SCADA RTU. Now let's see what you need to look for in a SCADA Master. First, you need to look for a system that has flexible and programmable responses to power inputs. First is the flexible and programmable responses to sensor inputs. So you should look for a system that provides easy tools for programming soft alarms and soft controls. Next, 24/7 automatic pager and email notification. There's no need to pay personnel to watch a board 24 hours a day. If equipment needs human attention, the SCADA Master can automatically page or email directly to repair technicians. Third, it should have detailed information display. You want a system that displays reports with a complete description of what activity is happening and how you can manage it. Fourth, nuisance alarm filtering. Nuisance alarms desensitize staff to alarm reports, and they start to believe that all alarms are non-essential alarms. Eventually, they stop responding even to critical alarms. Look for a SCADA Master that includes tools to filter out nuisance alarms. Next, expansion capability. A SCADA system is a long-term investment that will last for as long as 10 to 15 years. So you have to make sure that will support future growth up to 15 years. Next, redundant geodiverse backup. The best SCADA systems support multiple backup masters in separate locations. If the primary SCADA master fails, a second master on the network automatically takes over. It should be done with no interruption of monitoring and control functions. And lastly, there should be support for multiple protocols and equipment types. Single vendor solutions aren't a great idea. Vendors sometimes drop support for their products or even just go out of business. Support for multiple open protocols safeguard your SCADA system against unplanned obsolescence. And that's it for this video.